Good afternoon, good morning, wherever you're at. Welcome to August's TBC Power Hour. Today we will be talking about network adjustment versus traverse adjustment. The features that we'll be demoing today will be in licensed of TBC base for network adjustment and TBC complete for the traverse adjustment routine. I'm Joe Blecka. I am the product manager for TBC. Been in the role for about 5 months now. It seems like a hell of a lot longer than that.
That's Joe sitting on his father's knee.
Yes, yes. And before that, I was in support for about 3 years, based here in Westminster. I enjoy doing these power hours, especially when I've got someone like the gentleman sitting next to me to do all of the heavy lifting and share his expertise. Terry Clock.
Ready? Okay, so I am Terry Clock. I've been with Trimble for about 12, 13 years. I started off in the training department and then was with the TBC team for about 9 years. And now I'm currently in the support role for geospatial. Excuse me.
So thank you very much, Terry, for this. If you've got questions throughout the presentation, please enter them into the questions, and I'll get them and kind of filter them. I'll ask Terry if there's a time to fit it in between what he's talking about. If not, there should be time at the end of the session to discuss. And any questions that we don't get to live here, we will take offline. And we get your information logged so we can contact you with the best response.
Okay, and today we're going to talk about why do we adjust our data? What's the point? What are we trying to adjust out of the data? And I've got just a few PowerPoint slides to talk about this, and then we're going to go into some demo and compare some numbers. So let's jump right into it. Us as surveyors, we're using scientific instruments for measuring on the Earth's surface. So they're very precise and carefully engineered and constructed pieces of equipment. And no matter how many times we measure something, we can always get another number for it. We can always get a slightly different number. And because of this, the truth is somewhere in the mean of all that. Our measurements we take are actually approximations. And it's our job as surveyors to collect as accurate as information as we can. And in my opinion, no matter what the job is, get it as accurate as you can, as accurate as the equipment will allow you to get, using the proper equipment and the proper procedures. So where is this error coming from that we're trying to adjust out? One, it's the efficiency of its own built-in error. It can only measure up to a certain degree of precision. And a lot of this, like in these cases, we need to take care of our equipment. We need to make sure our optical plumbs are calibrated properly, and our horizontal and circular bubbles are properly maintained and cleaned, and the points, even on the tripod, the points that we use to plumb over need to be proper. You know, those can wear out over time. A fixed site tripod like the one you see here on the left, out of the factory, has a 2 millimeter standard error to it. So even with that, and a lot of people use this for static surveys and for their base, you have built into it automatically 2 millimeters. So we need to account for that. And inside the instrument, we've this is the Phase 2 display of one of the S-Series or VX instruments. It has some routines that you can run to keep so the operator can keep the instrument up to its highest precision as it can. But annually, the instrument needs to go into the lab to put on a bench, to be checked and adjusted as needed, and so we can keep it in perfect running condition. This scrolling text over here is some of the things that the service department will look at and adjust and fix if needed. The thing in the center is a collimation or a Phase 1, Phase 2 collimation error. You can see you're pointed at the center, but the crosshair maybe off to one side, and when you go from face 1 to face 2, you can see how you've got some angular error in there. So the instrument needs to be routinely inspected and adjusted as necessary. So when we make our measurements, these are some of the things that we have to deal with in bringing our numbers together to produce the most accurate coordinate that we can. And so there's a lot going on behind the scenes with our survey, and a lot of different pieces have to come together just right to get a good result. On top of our instruments and our equipment that we're using, we have environmental conditions that we have to deal with. We've all seen the effects of refraction and then curvature of the Earth. So the temperature should be recorded properly. You may not think it makes too big a difference, but recording the proper temperature for each instrument setup should be carefully maintained or entered. On top of that, in these days we have different coordinate systems that are published through our NGS data sheets or other sources, different qualities, and so we have to pay attention to what it is, what these numbers are, these coordinates we're using, where do they come from? Should we use a NAD 8386 coordinate with a 2011 or 2007 coordinate? How do we handle that? What do we do with it? So we have to pay attention. Not all these questions are going to be answered in this topic, but this coordinate control is a whole other issue. We won't get into that. In TBC, in general survey, the compass or Bowditch rule of adjustment is available to use. And TBC also includes the transit rule. The transit rule is an older rule that is used when the distance used to be taped, pull a stretch out of tape on the ground. It used to be that those tape distances weren't as accurate as the angles. So when you made an adjustment, you preferred the angular measurements over the distances measured, and that's what the transit rule is basically prefers.
These two adjustment approaches are in the traverse adjustment routine.
Traverse adjustment. Correct. And then in TBC, our network adjustment is a least square adjustment. And least square adjustment will not only combine the setups that you would select a setup in a traverse adjustment. If you set up on that point again in a traverse adjustment, that's not used. But in a least square adjustment, all available data is going to go into the adjustment. And on top of that, you can account for setup errors, centering height, centering errors, and height errors as well. So, and that's one advantage of the least square adjustment. So let's jump right into it. I've got a simple loop traverse here. I wanted to show this in a simple way so we don't have so much information it's hard to wrap your head around. And we can demonstrate the differences between the two and when you would use one over the other. So I'm going to hopefully push the right button. There we go. And go to this one. Okay, so if you've done the tutorial data in TBC, you might have seen this data set. And it's just a simple loop traverse that comes off of a couple of other points that were in that static tutorial set. If you haven't gone through the tutorials, I would encourage you to go through it. Even if you've worked with TBC a long time, I know once we get doing something, we continue to do it the same way that we know how to do it. But there are different ways you can do it in TBC. So you might pick up a newer, faster way, or you may know the fastest way. But anyway, what I do when I import a file is let's go over here and look at the imported files. Let me open that up a little bit. So what this job is, this is the fill loop traverse, JXL or job file, and if I expand it, I can see what we did. We set up on filter, we went to T and then all the way back to Y, then back to filter to close it off. Inside each of these, we did a set of 8 rounds. The default in Access is 3 rounds. When you do rounds, it automatically goes to 3, but you should be doing at least 4. And the reason for that is if you have one set of angles that are bad, you can get rid of it and still statistically be able to prove that you have 3 good readings that agree with each other. If you only do 3 and you get rid of 1, you'd only have 2, and that's really not enough to really prove you have the right answer. So I typically do a set of 4, but in this case I did 8. So inside of each of those, you're going to have the back sights and the foresights measurements. And then next in the file, I have the control point listing that I made an adjustment and imported all of these points in an ASCII file. And those are the coordinates that we're going to use on filter and 5 to do our adjustment. So I kind of become familiar with this. What I also do to keep a clean project, this is the FXL file that we're not doing any feature coding, and at the time of the import, this file wasn't in the same directory as the job file, so I'm going to just remove it. It doesn't matter. If I need it, I can import it later. Now I'm going to take a look at my flags, and I will sort them in order from lowest to highest. You can just click this back and forth and see what that is. So let me sort it back this way, and I see from all my mean angle readings, I have some horizontal mean angle readings up to 5-second difference, and then from the verticals from 4 to 11 seconds. In this short traverse, I'm not concerned about any of these values. So to keep my list of angles, my list of errors short, I'm going to fix it where I don't see these anymore. But if it was a problem, what I would do is click on one of the problems, hit mean angle report, and then I can easily see where this 11-second is, and it's right here. What I would do is uncheck that, and it would remove this one and all the other points in this setup, and then it would calculate a new mean for me. But in this case, I'm not too concerned about it. So to get rid of these flags, since I've looked at it, I know what they are, I'm not concerned about it. I'm going to go to my project settings and then computations, mean angles, and I'm going to tell it, don't show me anything more or anything less than 13 seconds. I could say 11, but the 3 was already there. So I'm going to just say that, and there we go. Now I've got this one about a station setup plus. I'll expand the imported files and see what they're talking about. Now this is going to be highlighted in red once we see it, and here it is. If I expand this, I can see that probably what happened is they started their station setup plus, realized they pushed the wrong button, got out of that, and started it again using just single backside. So this adds nothing to the project. Even if it was least square, this wouldn't add anything because there's really no observations. So I'm going to delete that as well and recompute. And now I have 3 more flags that I need to take care of. If I let's look at the first one for filter. I'm going to select filter, right-click, and get a point derivation report. Now, filter can be, and TBC can compute forward and backwards in this. So what this is telling us, let me minimize that a little bit. What this is telling us, it is this used to calculate. It's using the control point status from our CSV file we imported to compute this point filter, and then all the other ways it can calculate point filter, show it below it, and then the differences in between those coordinates are shown here. Well, this was this grid file, this grid coordinate here was one that was used in the field, and it was an unadjusted coordinate. So I'm just simply going to find point filter, find that coordinate from the JXL file. I get the properties of it. You can either disable it and the flag should go away. Or in this case, I don't need it. I know what it was there for, and it does me no good, so I'm going to delete it. Same thing actually with 0.5. It's the point that was in the file to begin with, so I'm going to delete it as well. Recompute, and I've got one other flag left on point W. If I look at a point derivation report on W, I can see, and if you look at W, it's got two ways to compute it, from V and from X, and that's just what it's showing us, from V and from X. There's a difference in the distance, right at 4 centimeters actually. And when I went back and checked the field notes, I found out that we entered the wrong prism type in the field. So I'm going to select on this vector, and we used the wrong prism type when we occupied X and went to W. So I'm going to click that one of those measurements. It doesn't matter which one, and because this is all part of a set of measurements down here at X, I believe. And this is where I'm going to change the prism type. We use two prisms, the VX and the 63 millimeter prism. Now this is asking me, this measurement, this observation was part of a mean angle record. Do I want to change all of those? And I'm going to say yes, because we use the same one we use the same prism for the whole setup. Now when I recompute, now the point W and all these other points are within the tolerance. There's still some differences in here. Like if we checked for V and get a point derivation report, we will see some differences when it was calculated from W and then calculated from U. Just small, but they're there. And this is the type of stuff we're trying to resolve with our adjustment. If we just use, let me go back to that. If we just used what we have in the job right now, it's not bad, don't get me wrong. I did it, so I know. We have, it's just 1/1000th of a foot, and we have almost 1/100th of a, oh, this is meters, I'm sorry. We have a millimeter in the easting, and we have a millimeter overall, and then 8 millimeters in the distance. So if I just use these coordinates, I know there's error in our network that we haven't adjusted. So what we're going to do now is go through the traverse adjustment. And so I'll go to the survey menu, adjust traverse, and since there is not one, I'm going to create one, call it first, and create. TBC will look at the observations you have and see and try to figure out what you want to do first, and then you can verify, yes, I want to go from filter to T to U, and then I hit plus, and it goes along and finishes the rest of it for me. Now this part up here at the top below the stations is you see you can choose a different backsite, and what these two items are used for is you started or ended the traverse with a resection. TBC will pick the first point in the resection and put that in the list. Well, you might have shot 5, 3, and FSI during your resection. That would have been bad geometry, but you might have did it anyway. And you may want to use FSI, so that's where you would change that here, saying I want to use FSI if that was the case. Same thing with the ending. But in this case, we started and ended on the same point, so we're going to leave it at that. I'm not going to talk too much about the proportional to distance and proportional to distance. The other option is for equal proportions of that. With this small traverse, these short legs are all about the same distance. Choosing either one of these methods will get you about the same result. When you have longer back sights or longer foresights, that's where this could make a difference. The adjust horizontal, we're going to use the compass rule method. The manual mode, what this means is it's only going to readjust the traverse if we come back to this command and run it again and compute it. If you do it in automatic, adjust automatically, if you later come back and say, you know, when we set up on T, we actually had an instrument height difference, and you enter the new difference you enter the new value, your traverse will automatically compute for you, changing the coordinates that you previously were using. And for me, I don't care for that. If I want it to keep the same coordinates until I physically change it myself. So with that, we've got our traverse ready, and we're all ready to adjust. What triggers the adjustment to run is just switching this tab across the top. And from that, we can see, we get all the information about our settings, what we started on, what we ended on, the stations. And then before the adjustment, we can see we have a 2-second closure ratio or angular closure on this traverse. And then here's our distance closure. Then after we adjust our angular error, this is what we have for distance closure. And then after we adjust for that, we show you that there is no more error, or that error has been accounted for. And in this traverse, this is pretty good. 185,000 for closure ratio is very good. And for me, I've ran these traverses before like this, loop traverses, and I would be satisfied with this, and I would use these coordinates in the job that I needed to do it in. But when you do a loop traverse, all you're doing really is verifying that your work was done properly, that you set up properly, as long as your closure ratios are good, that is, and that your instrument is in good condition, but you're not verifying anything about the control. Either one of these 2 points could be off by feet or meters, and you could not detect that with this type of traverse. But if you trust your coordinates and you're good with that, then that's good to go. Then we can go on and do our work that we need to do. So where are we? Here we are. We've got our traverse. Here's our adjustment with our traverse adjustment. Now let's take a look at how this would look in least squares, a least square adjustment. And I have another job for that. Now this is the same job. I have it set up the same way. Everything's exactly the same. So I'm going to go right into our survey tab and go to adjust network. Now because when we do a least square adjustment with static data, you know, we do a minimum constraint adjustment and then work up to the fully constraint. But because this is just a single loop and we've got filter and 5, if we do those, it can only constrain it one way. So this is a minimum constraint. So I'm just going to select all of them. Even though some of these points weren't even used, it doesn't really matter. So I'm just going to run the least square adjustment and find out that our reference factor is 18.6, our chi-square test failed, and our degrees of freedom is 22. Now, you say, we measured a lot. We took a lot of measurements in this, and our degrees of freedom is only 22. Well, if you look up in our project settings under network adjustment, the general tab, this mean angles, it says use mean angles results. This is the reason our degrees of freedom are so low, is because of this. And this is actually what we should be doing. Let's show you what it would do if you said use individual observations. Now before I do that, when we set this up, we set tripods up, prisms, instrument, and we did 8 rounds back to back. We didn't go back and check filter. We didn't go back and check U. We didn't check anything. We just did 8 sets of rounds, which made, if there was an error in any of our tripod setups, this set of rounds would not detect that. So we really have a precise mean angle set of rounds, but all the individual observations have correlated or could have correlated errors. And because of that reason, we only use the mean angle information. But if you wanted to use individual observations, you can see that the degrees of freedom goes up quite substantially, because now it's counting all of our observations as if they were independent of each other, and we know that's not true. So just wanted to show you that. Let's go back to network adjustment and change this to use mean angle. And what that's going to do, this high number, it's going to inflate our statistics and make it look like we have one. It's going to make it look like we have more data than what we really do, and it's going to make it look like we're more precise than what we actually are. So I'm going to get this back to reading to 22 and show that we're still at 18.6. Let's look at the weighting, and we can see that we want the reference factor to be about 1. 1 means that our estimated errors are equal to the errors that the adjustment found throughout the network. And these error ellipses, what this is at U, point U or any of them, this elongated that's perpendicular to the line of this traverse leg would indicate most of the error is it's an angular error more than distance error, and you can see that all the way around until it gets back up here. But at any rate, all we've done so far is kind of basically what we did with the traverse adjustment, because there's not much else it can do with this in least squares. But we haven't accounted for all of our error that we have yet. So we can try to improve these numbers before we even try to apply a scalar to our error estimates. So what we do is we go into project settings and default standard error. And first we look at this. Our standard errors for our measurements are going to come from the imported files, and I'll show you that real quick. If we look at the properties of one of these mean angles, we can see the horizontal, vertical, and slope distance standard errors. It's going to use this information for each of these setups. Let's go back to project settings, default standard errors, and we are telling it to use the project settings for the centering errors and the height errors. Now we only have total station, so we're not really concerned about anything else. So we're going to go into total station. And so far we're saying, when this says 0, we're saying we have no error in our centering errors. Our plumb bobs are perfect. I mean, our optical plummets are perfect. Our measuring up is perfect, and there is no error in there. But we know that's not true. Let's start off this by saying our centering error, even though we just adjusted these tribracks, we know they can be off. It's very hard to get them where there's absolutely no error. And using our tape measures, we measure these things up at a slant, and it's really hard to read these numbers properly. We know that there's at least a few millimeters of error. Or these, I'm sorry, these are numbers that I was using for feet. So let me lower these down again. Let me go to about 2 millimeters for the centering, and I'll just keep it at 2 millimeters for the height errors. So I am going to do that and then go back to network adjustment and run an adjustment again. I haven't changed anything except those readings. And now you can see really quick that made a difference. It made a big difference. So what it's saying here is this, for horizontal angles, it's 0.32. It's saying that we don't have that much error in it. If it was 1, then we would know that we have about that much error in our traverse. But in this case, it's saying with this information we gave it, these observations, that we don't have that much error. The vertical angle and the slope distance is a little bit opposite. We do have a little bit more error in the vertical angles and the slope distance. So what we might do now, we can adjust these numbers. Now the centering error is going to account for some slope for the horizontal angles and slope distance, and our height is going to mainly work in the vertical angles area. So let's see. For the instrument error, I will put this down to 1 millimeter for the instrument, and I will leave it at 2 millimeters for the backside because it doesn't have as good of optical plummet. The height errors here, we were a little bit low on that, so I'm going to raise this up to say 3 here and 3 here. Now we're probably not going to get these all to equal 1 altogether, but that's okay. What we're trying to do is to get them a little bit closer to reality. If we look at point V here, we look at the results and see we're right at 1.5 centimeters and 2.5 centimeters on the easting and 2 centimeters on the elevation currently. But let's go ahead. We could continue to tweak these estimated errors and until when we keep adjusting these and they stop making a difference is when we want to stop doing that. And then we can apply scalars to the number to refine our adjustment a lot better or better. And now we can see our reference factor is 0.97. It's right at 1. Our chi-square test passed. And now our error estimates for point V are at 6 millimeters and 26 millimeters in elevation.
Hey, Terry, I got a quick question here. Can you go over why you held all the points fixed in 2D for the least squares?
In this case, I held all these points, and it's done right here, because there's only 2 control points that these observations are connected to. If I were to hold one and not the other, then there's not much information that's connected to it. So holding it or not holding it in this case would do the same thing. I could just uncheck them and run it, and our numbers over here at the results would be the same. Where this would make a difference is if I were to say point V was also a control point, then I would start to influence the least square adjustment to fit to this point V, and I would start to introduce positional errors into these observations. If the position between V and filter had some small bit of error in it, it would now be, V would be forced to be fit to U through these observations, and I would introduce more error into our network than what we actually do. So what we want to first do is just to check our data to make sure it's working good, or it works good together. And so after this adjustment, so we're here at the end, and I'm not going to adjust these anymore. What we want to do, what you would want to do in a least square adjustment minimum constraint, is look at the adjustment report. This will tell you if, this will help show if you have any blunders in your data. But it can also take, and if you allowed it, it would take blunders, and if you didn't remove them, it would disperse that error throughout your network. So you want to make sure that you have all your information is good, all of your height measurements and centering is good and well estimated. And how you would see a blunder if it's big enough. We won't go through the whole report right now. There's be another time for that. But you would look down here at your adjusted information, and anything that would be considered an outlier would be red up here in this area. And in this case, the highest one we have is this ellipsoid distance for point filter. Now, if this was high enough to be an outlier, what we would do is we would go to this mean angle report and find out if there was a angular outlier in that, if there was a flag on that point that should have been, or in that set of observations that should have been removed. We might disable it and go through the network adjustment again. Now, if we do that, then we would want to start over. We would want to clear our results, do another adjustment, do the same steps we did before, get to this point, apply a scalar, and do the adjustment again. So if you add or remove anything from the least square adjustment, you need to start over from the beginning. You wouldn't just add something and keep all these numbers as they were, because that observation that you added or removed is now going to add to your results. Let me close this. So let's look and see where we're at with these numbers versus the least square versus the traverse adjustment. So this on the left is from the traverse adjustment, and the northern and eastern elevations on the right are the one from the least square adjustment. Then we have the deltas between them. And because this is a simple loop traverse, there's not much difference in the information that we get. So, yeah, and these numbers are in feet, so excuse me, they're not meters, so they're actually smaller than what they look like because they're in feet. Our project is currently in meters. And you can see, so there's not much else the network adjustment can do because it's a pretty simple adjustment. But let's see what happens if we add more information to it. So what we're going to do now is go back to our traverse adjustment. And we went out just to check ourselves, and we added a couple of more observations to this. This just means there's the same point numbers in our file, and we're going to merge them. So we also shot from point U, we shot over to point 6.2, and then point Hannah. Let's go back to our traverse adjustment. Now let's create a new traverse adjustment with this new data. Second. And we'll create it just the same way. We'll leave everything the same, and we'll go to results. Now what's happened is you can see these observations that U and X were not in here, and one reason is because they were just 4 sites. We did not occupy 6.2 and Hannah. But you can see down here in the flags pane that we didn't hit these 2 points right on as you might expect it would. This point over here to Hannah is a decimeter off, and this one over here is 3 centimeters off. So adding these occupations or adding these observations to our traverse adjustment made no difference to our coordinates that we have for these 2 points. You can see it's exactly the same, but we can see that they're off. But with traverse adjustment, we really can't do anything about it. So let's try this with least squares and see what happens. So let's just drag in this file in here. And I'm going to clear the adjustment because I'm doing it all over again. Now we can still see these flags over here for point 6.2 and Hannah. They're still there, even without an adjustment. So we're still using our setup errors that we had defined previously. So I'm going to hit adjust. And now what the routine has done, it's used, because I said over here I want to hold point Hannah and point 6.2, it's held them as control points. And the differences that we've seen in Hannah and 6.2 before, we see that those differences are no longer there. Now we have another difference up here at 5. So what this means, let's go ahead and finish this up, 264. So because we have more control points, we're kind of constraining our network a lot. We're constraining all of our adjustments to the control points that we have held fixed. So now if we let's go ahead and I might do something if it was real world. I might come back in this and adjust these a little bit up a little bit more because we're saying we have more angular error than this. Let's just go to 3 millimeters and 3 millimeters here. Vertical looks all right, and now I'll do another adjustment. And we brought this down a little bit, and we're still failed here, but we're going to apply scalars to our error estimates, recompute our adjustment, and show that now what we have here in the network. So let's take a look at the coordinates that we've produced between these adjustments. Okay, here we are, we did that. So this is the top is just what we did, what we saw earlier, but we've added this information for day 2. This is when we held point Hannah and 6.2. And now if you look at it, the numbers have shifted a little bit. The northern and eastern has shifted, the elevations have stayed about the same. But what this indicates is back in our traverse, our adjustment, is that we're fitting not only just to 2 points now, we're fitting our entire traverse to all of our control points and not just 2 of them. So we've actually best fit our traverse to all of our control points, not just to 2. So any difference that we've seen in here has been worked out because now we've held these occupations or these measurements to these other 2 control points, and it has slightly rotated our traverse to best fit our other control points. These 3 millimeters here, if we looked at it, it would just say that the least square adjustment differs from the observed information a little bit, slightly, and we know that this because we're constraining our network a little more. Maybe our overall network isn't as tight as what we initially thought it was, but now at least our traverse is best fit to our entire network and not just to 2 points. I think, let me see, is that about it? That's about it. That's all I had, Joe. Hopefully I didn't confuse too many people, and I might have answered a few questions. I wouldn't be timid about using least square adjustment if you haven't used it. It's a very good tool to use, and if you're new at it, we'll just continue what you're doing, but hit least square adjustment with this information and see if you can work through it. I believe we have a tutorial on least square adjustment. You might check that out.
Yeah, and I can talk to a little bit about those here. So we've got plenty of time. I'm going to do my little finish up shtick, and I've got 3 questions here from the audience that we'll be able to get to. So got to plug our next Power Hour. These Power Hours occur every Wednesday, the last Wednesday of the month, I should say, which falls on September 27th in next month, which is the Intergeo Geospatial Conference in Berlin. So Larry Rosenbaum, who is the product manager for Trimble Clarity, and I will be presenting and introducing Trimble Clarity, which is a new cloud-based geospatial data viewer and collaboration product. I'm very excited to introduce that. It is a standalone product that will be integrated right now within TBC. So hand in hand, viewing your Trimble Vision station-based data or your Trimble SX10 scanning total station data. But I hope you can join us then. Since it is a little bit different, we'll be in Berlin instead of Westminster, Colorado. We're going to just do a single session, and unfortunately, given the time zones, that session will be in the morning. So this, or at least the Americas morning, this afternoon Americas session won't occur. It'll be about 4 p.m. I think local German time, which is 8 a.m. Mountain time. Go ahead, Terry. A couple of TBC resources we like to cover. There's a growing online community open to the public on our Trimble community page. It's been really encouraging to see users interact with users on this forum. There's also monitored by Trimble and TBC staffers as well. So great place to discuss successes, failures, questions, enhancements. Of course, we love our software here, but we know it's far from perfect and has much improvement. So we would love to hear from you, either on that community page or the TBC Facebook page. Should be easy enough to find us. We have a very active YouTube channel. The user is TBC Survey that we've got, I think it's 183 videos on. We are a couple of weeks away from a release, and I bring up that with the YouTube video channel because we will post new feature introduction videos, just quick, really easy to digest, 3, 4, 5-minute videos going over new features that we've added. So check back in with us there once you see the new TBC has been released. And then also the TBC Power Hours, we're going on more than 2 years of doing these. The beauty of that is that all of the content has been archived and available for viewing and downloading after the fact. So check us out there. If you've got any suggestions for TBC Power Hours, please let us know there as well. And then some additional resources. If you like what you see, or if you're running on a different version of TBC, or if you're not sure what version you have, the latest version is TBC version 3.90. That is available at this URL. If you've missed any of these links or URLs, don't worry about it. We'll post this recording here in a day or two, and the presentation will go along with it, so you'll be able to pull the web addresses as well. If you don't already have a TBC license, contact your Trimble partner. And if you don't know who your Trimble distribution partner is, on Trimble.com, there is a dealer locator in the upper right corner, at least that's where it used to be, that's a geography-based tool that will help you find the nearest dealer closest to you. And like Terry mentioned, once you get started in TBC, there's upwards of 30 onboard TBC tutorials with sample data sets. There are adjustment tutorials that you can walk through. You've got a PDF and the complementary data. Some of these control points may look a little familiar as well if you get into those tutorials. Check out our YouTube videos or ask a question on the TBC community. I would like to, as we get into this, a couple more questions here. If you do use TBC for adjustment package as a traverse or network adjustment, least squares, please let us know. Type in your response. If you don't, though, we're very curious about what adjustment package you do use outside of TBC. StarNet immediately comes to mind as a common classic adjustment package. So if you wouldn't mind just letting us know, type your response in, and we'd would like to have that information. All right. A couple of follow-up questions here for Terry. So back to the question of setting the 2D fix on all those points in that closed loop. Would it have been any different, or would you have taken a different approach with the least squares if this traverse was an open-ended traverse?
That question was asked this morning too, I believe. In the case of an open-ended traverse, we have. Let me switch back to least square here. In the case of an open-ended traverse, we have a comp engine, a computation engine. Every time you press F4, the little recompute button here happens. It computes through the entire network of what it has in the project. And the comp engine, when you have an open adjustment, let's make an open one, and let me undo a few things. There we go. Now I'm going to clear the network, and I will go through and delete point filter and point Y and recompute. Now we have an open-ended traverse. There's actually the value that you have for point Y is as good as it's going to get on an open-ended traverse, because the computation engine is already using the mean angle records of the observations, and there is nothing. When you get to Y, there's no other point to go to. So in this case, well, let's just see. I may prove myself wrong here and have a slightly different answer, but you could do this. I won't. There's probably another question. You could compute this least square. What I would do to test this is go to our home, get a point spreadsheet, copy this information to the spreadsheet by right-click, copy, and paste these numbers into a spreadsheet. Then I would go through and do the adjustment again, or the adjustment. Now, it's going to make some difference with your setup errors and centering errors, so I will correct myself there. It will account for that, but there's not much else it can do with this ending coordinate, because there's nothing else beyond it. The mean angle information will correct most of it, so when you do an adjustment like this, the setup errors is what would make a little bit of difference in here. So maybe a long-winded answer.
No, that's great. Thank you. A couple of questions here about mixed data sets. Do you recommend performing a single network adjustment on GPS and conventional data together, or would you separate them out?
What I would do is I would probably start with the GPS data, run a separate adjustment in the beginning, and a minimum constraint adjustment on that. It's by itself to see how well that fits together. Because when you start adding conventional and GPS together, a lot of information, and you run adjustment, any errors in either one of those is going to be spread throughout the network, or has the potential to be spread throughout the network. So I want to make sure all my GPS works good within itself. I might do just a traverse adjustment to make sure that my traverse is looking good, and then I could combine them together to get an overall adjustment. Now, if I had, and I actually do have it, but we don't have enough time, the control and the observations into all these control points here, what I could do is do a least square adjustment on my traverse points, on my GPS points, then import my fill loop traverse and do a least square based on, then do a traverse adjustment based on the control points that were defined in my least square adjustment. So I'll be using both adjustments in one package. But if you have optical and GPS in your project and do an adjustment, it's going to use all available information. So for me, I would try to single out the two different sets, adjust them separately to make sure they're okay, if I can find any outliers that way, and then bring them together once I'm confident about my information.
So that kind of speaks into this follow-up here. So how do you appropriately weight each data type? You would think that at least from a measurement comparison within itself, the conventional data is more accurate than a GPS data. But it sounds like you incorporate that. Every situation is obviously different, depends on the quality and the confidence you have in the data. Interesting.
Right. Some of the optical data between these close points is going to be more precise as long as the proper care was taken in making the observations. But in TBC, you have the opportunity to tell it how to weigh each individual group or variance group of observations. You can weigh the optical a little bit heavier than the GPS, or vice versa. You can weigh it whichever way you want to weigh it, and that has a big part in how it's fed into the adjustment, or how it's weighted into the adjustment is how much weight you put into it. And in this case, we shot 8 sets of rounds. That's quite a bit of measurements, and if I would trust that over maybe a GPS measurement between these 2 points, so I would try to put more weight into my optical observations. And the way you would do that is either in default standard errors for GPS, you have the option to use the baseline processor, and that's what you should use to get the standard errors out of it. But if you wanted to weigh it, you wanted to ensure that it was weighed a little bit less, you could tell it to use the project settings, and then go in here and say, for your default standard errors for GPS, use these numbers as opposed to what came out of the baseline processor. So there are different weighing strategies, but if you don't enter something here, it's going to assume everything is equal, and we know that's not the case. If you have multiple crews doing a job, or multiple instruments on a job, they don't have the same, they're not adjusted the same, so you'd want to try to weight them accordingly. another long answer.
No, it was great. Changing tracks a little bit, how does the network and traverse adjustment handle side shots and topo shots and between the two different approaches?
Okay, it really kind of does the same thing with side shots. Say we were okay. Well, let's undo a few of our undos. Oh, I guess I have to drag it in again. Yikes. Okay, so let's say that 0.62 doesn't have a coordinate, and it's just whatever is computed in here. So what's going to happen is we set up here on point U, we backsided point T, and we turned into 0.62. So when you do a least square adjustment for this type of data, any adjustment between U and T is going to affect where this point is put. If it is tweaked with a couple of seconds or in here some way, then the new azimuth between U and T is going to be used to calculate where 0.62 is going. If you have RTK data, it's going to use a weighting scheme that when you collect RTK to use in the network adjustment, you save the QC1 and the QC2 report, and it's going to use that information to weigh and how it's going to be adjusted. And that single observation is what's going to be used to the position. Unlike here we have this observation between U and T, sorry, but we also have a way to we have other ways to compute these 2 points. So so when you do an adjustment, a least square with side shots, it will adjust the side shot points optical, but only with respect to how the setup and the backside were adjusted. Hope that answers the question.
Yeah, I think so. Well, we've got a couple more minutes. If you've got any last-minute questions, please type them in. Two things to note since Terry's got TBC open right now. If you are used to using separate projects to handle your different data types, that seems to have been a common question here in this session. You know, one TBC project for, for total station conventional data and one project for GNSS data. That is absolutely okay. But know that TBC in a single project can support those different data types as long as they're both running on the same type of coordinates, whether that's a known projection, local site calibration, ground-based coordinates with a scale factor. That is an option. And also what you can do to test that out, if you're still a little on the fence about working with multiple data types in the same project, is if you see in the screen right now on the survey tab, right below where the survey tab entry is, there's a merge survey projects. That command will allow you to merge different data projects, different VCEs into a single VCE. So give that a shot as well. Terry showed the network adjustment report, an initiative that we've taken over the last couple of release cycles is to add further customization of reports and have started to allow customized reporting. And network adjustment is a type that we've added for customized reporting, and that is a Microsoft Word interface where you'd be able to edit formatting in Microsoft Word just as you would in any Word document, but link back to your TBC data types and to really allow for a customized product, allow what you want to include in your report if you want to personalize it with your company name, logo, things like that, and a whole slew set of data to add in that.
So I just kind of demonstrated how the side shot was adjusted. I created this point 1111 on top of 0.62 before the adjustment, ran the adjustment, and now you can see how 0.62 was adjusted after the adjustment. And it was 5 centimeters, which was quite a bit. Let's do the same thing, since we have time. Let's do the same thing with totals. Oops, not that. With traverse adjustment. Okay.
So while you're doing that, Terry, can you have multiple least squares adjustments in the same TBC file?
No, you cannot. One adjustment per. Now you can see in this case the traverse adjustment. Adjusted the point a little bit different, and it put it to the south of the initial location of 0.62. And how much did it move it? 3 millimeters, while the least square adjustment adjusted it a lot more. Let me check. Yeah, I had point Hannah adjusted. I used point Hannah as a fixed point. That's why it moved it a little bit. It moved it more in the least square adjustment than it did in this one, because Hannah in this case does not influence the rest of the traverse adjustment. And if you want to look at that a little bit further, what I can do is I can go to this point Hannah, and I can get the properties of it. I can add something to it, recompute, and now we can see where we observed Hannah and where the control quality coordinate was for Hannah. So earlier when we held Hannah as fixed, you can see how it would have pushed and rotated the traverse to the east a little bit more, to the rotated around point filter. So that's one of the things I do as well in troubleshooting data is kind of rename points, see where this point computes it, see how that computes it. If I wanted to put these back together, I could just undo, or now I could go to merge, which is under, where's it at?
The merge.
Edit, merge.
Points.
I've already got them selected. I want to use point Hannah, and now I will hit apply. And now if you look back here at these observations for Hannah, it's back to the same name. So just a little troubleshooting tip there on figuring out how your data is computed if you have a problem and where the problem might be.
Okay, one more question here. Back to the mixed data sets. Can you tell the network adjustment routine to only look at a specific set of data, like GPS only?
No, you can't. It's going to use everything available. But you don't have to. If you do that, you don't have to. Where am I at? Survey. You don't have to, like on point Hannah and 6. Well, this isn't mixed data, but you don't have to apply a scalar. So if we had if we had GPS and optical in here, we could apply a scalar only to the post-process vector and not let the optical data influence it as much. But what is happening, these observations are also going into the computation of this, and it's having an influence on the overall network. So it really, you can't do that. You can't. I kind of wish you could say isolate and do only GPS, but all of the observations in here are going to influence the outcome of the network. So I guess my overall answer is no, you cannot do that. Yeah. If you wanted to do something like that, then you would bring in your you would bring in the GPS, do your edits, do an adjustment, and then bring in your optical information. That way, the optical information won't have an effect on the GPS observations. And then your optical would be based on the control points. Even if you didn't do an adjustment, it would still be based on the control points that were adjusted. And that would be a viable option as well, as long as you trusted the optical field work that was done.
Okay, one more question here, and then
that earlier.
We've got everybody. We've still got a large chunk out there. I know we're running a little late, but I promise this will be the last one. Can you comment on applying those standard errors to those fixed coordinates that you set as fixed?
Yeah, when we say fixed over here, if we go back and look at our report, what that means is this right here. You can't have a zero, you'll get a divide by zero error. So when you held a point fixed, this is a metric job, so this is what, like a nanometer? I'm not 100% sure on that, but it's a really small number. You're saying that there is absolutely no error in these measurements, and we know between 0.5 and filter, it's not perfect, and there is no perfect answer. So when you say fixed, that's what it means. It means it's not going to allow the observations to adjust these coordinates. If you, for instance, your point filter, your point filter in 5 is what we use for this. You can come through here and say, for 0.5, if you expand this, we have the option to say 0.5, well, let me open filter as well. Point filter will hold fixed. We're not going to allow it to adjust, but we're going to say that our azimuth, or that our position for our standard error for 0.5 is a little iffy, and maybe it was a nail in the ground and you come back and it's slightly moved and you're not too sure about that, or whatever the case may be. You could come in and say, I'm only sure about this point up to about 3 millimeters. And now when we do our adjustment, I forget how we have this. Oh, I'm in the traverse adjustment. It will allow a little bit of movement in this point, in this azimuth between the 2 points. So that's a good point. I mentioned that earlier today. And when you're mixing control, let's see. Let me go back. When you have a case like this, where you have your orders of your points, second order or first order, are they're different, then you can, in your adjustment, tell it where am I? That one of these points has this much precision, the other point has this much precision, and you can actually, if all of your equipment is in good working order, you're using the same type of equipment, you know the precisions of your control, you can actually enter this information about your control points. You can enter the standard errors for your setups, and if all your measurements were precision, you can most probably adjust the network without having to apply scalars, because you've accurately modeled the information you're giving the least square to do its adjustment. Some of the error that we're seeing in here, because we're not modeling the errors properly, and as long as the observations are homogeneous and you properly weigh the control coordinates, then you can really zoom in on this and get it modeled properly, and the results here would be very near 1, and that's the goal, is to get this your estimated errors to equal the amount of error that's being found in your observations. So that's a good point.
Great. All right. Well, thank you, Terry. I think we've answered all the questions, and if we haven't, I will get to them offline and follow back up. But thank you, everyone, for your attendance. Thank you very much, Terry, for your expertise and your time this afternoon and this morning. And we hope to see you a month from now as we introduce Trimble Clarity in the September Power Hour.
And I'll see you tomorrow, Joe.
I hope so.
Thank you.
Thanks, everyone.